2 days ago, I was watching Paul's video from PS Audio, and sometimes I skim these things, sometimes I don't. But anyway, he was brought up a topic about computer noise and how it's an issue, and well, a lot of computers are noisy as hell, and it's pretty much a given. I mean, some are worse than others, and but it was a 5-minute video, and he kind of covers things. Anyway, I figured we'd do a video on that, just kind of expand on it a little bit too, and things we found out might help.
This is a common complaint with computers. Everyone always says, oh, computers are such a noisy audio source. Use something else. And the trouble is, most things that people recommend using kind of are computers anyways. So it doesn't really mitigate the issue. But it is a common enough issue. There's things you could do about it. And I think there is some clarification needed to be said about what Paul did. It was a perfectly fine video, but a little bit more in-depth might be reasonable.
A little bit, yeah. Like one thing I know, we've dealt with noise for decades at this point, coming from the cable side of things. And shields, the way they convey noise, the capacitance of the cable. There's a lot of things that affect noise. And we should probably define what noise is, because a lot of people think noise is audible, like hum. Like,
well,
okay.
It can be.
That's obvious noise. All right. Yeah. That's not what we're talking about here. That's something, that's a ground loop.
That's pretty common in the analog domain. You hear things like that audibly, and they cause real nuisances. But in digital, noise is far more complicated.
Yeah, it's high frequency energy. It's not in the audio band, but it does transpose itself to messing with the audio.
Well,
that's what we want to explain. Yeah.
It may, in some circumstances.
Yeah. Well, especially at the D to A process. Like that's really where it gets in. And, but it happened, but that's not even really accurate. High frequency energy can go through analog electronics and get rectified and turn into hiss.
Potentially, depends on the design.
Yeah. So, I mean, regardless, noise is noise, and it raises the noise for the system when it gets into it.
Well, and there's multiple sources for this noise. I mean, it could be RF or from the wall, so.
Yeah, right. It could be electrical based.
Most of it's voodoo, and you can't really see or hear it.
Airborne's a bit.
It just shows up.
Yeah.
If you can't see it.
If it's in the air and you've got things like, like light dimmers, for example.
Oh, yeah.
Tend to throw out noise on the electrical line, and they radiate the noise in the air.
Yeah, you can hear them sometimes.
So,
when you dim them.
Yeah.
The dimmers themselves.
Yeah, like you change the brightness, and it changes the...
Yeah. Yeah, and some poorly designed power supplies, especially switch mode power supplies, which are very common these days, some of those will throw a lot of noise into your electrical system in your house. And depending on how low impedance your electrical connection is to the grid, or how many things are on that circuit, or whether or not your audio stuff is on the same circuit as other devices, sometimes this can cause an issue as well. You can get AC noise. And the trouble is people commonly say, well, that's the power supply's job to deal with it. And it is. The power supply should, ideally, eliminate that noise and cause it to be not an issue. You have perfect DC coming out. However, in practice, that's very, very rarely the case. Yeah, usually you have some noise.
High frequency energy bleeds through. I mean, it's not, when people hear the word filter or shield, they think it's like some...
magic.
Like you're in a bank vault or something.
Now there's no more noise.
No more noise. Yeah. Absolutely not the case. I mean, shields come in all different flavors and sizes and topologies, and some are effective at some frequencies better than others, and some are not effective at all at some frequencies. And same with filtration. Line conditioners, filters, they can help in some areas, some frequencies of noise spectrum, and in others it just bleeds right through, gets right through. So none of this stuff is perfect. The only way to make a perfect filter is you'd have to know exactly what noises you're dealing with and design a filter around that. But in the case we're talking about, where we're dealing with wide band energy, RF energy, it's all over the spectrum. There's no one particular frequency or source to pin down. So you're trying to stop this, right, with basically a Band-Aid is what you're using for the most part, because you don't really know what you're dealing with. It's just there. It's in the home environment. It's in the commercial environment.
And it could be constantly changing, too.
Right. It could vary. Like you said, with the dimmer, you change the thing, you vary the frequency.
Something as simple as just a normal switch.
That's an impulse. That's an electrical impulse response. Yeah.
But the challenge seems to be, since there's so many different sources, as a result, there could be wide variation in how much of a particular noise or what frequency at which the noise occurs in your home and your environment. So what seems to be most common is a designer that designs their electronics or their amplifier or whatever. They don't have these particular issues, and so as a result, they design it for the environment they have.
Yeah,
in their environment, it works fine.
On a test bench or, where you're doing the engineering in that, it's perfect, right? There's no noise there.
Oh,
but
it's
in
like
the real
that room that Apple has for their RF room.
Oh, yeah.
They got a nice.
I didn't see that. Is the new one better than the old one? I remember seeing the old one.
Yeah.
They don't really show
they
it.
don't
They kind
show
of
it much.
glance
That's like
it
an
over.
amphitheater,
Yeah,
man.
yeah.
That's not even a room.
Right, but
Yeah.
the lengths that people go to be able to measure the radiated noise are extreme, and that's the trouble. These small-time manufacturers don't really know in absolute terms how much noise this gear could tolerate and how much noise it radiates potentially into other gear.
Well, not only
because
that,
it's so incredibly difficult
not only
to
that,
measure.
in the engineering of it, let's say they design the unit, all right, and it goes through CE testing, UL testing, whatever, and one of the tests is for noise radiation, right? All right, so they make a unit that passes that test.
Right.
They get the stamp of approval. Now you go into production. We could find a cheaper capacitor for this. We could do this, right?
Yeah.
Now all of a sudden the thing isn't really meeting the spec that it did on the initial engineered.
Actually, recently, that's becoming more and more of an issue in the PC space, especially since there's so much supply side constraints. People are picking and choosing components that
You can
work,
get.
are serviceable,
right.
but
Yeah,
they
you could actually get
change
it.
the function. Like you could get these parts, but
Yeah,
now
right.
this SSD has a different controller and it doesn't perform the way it did, or you're using a different chip or something like that in a power supply, and as a result, the efficiency isn't what they claimed. That's a big issue, and unfortunately, it's common, and you don't really know what your device has. So you say, "Oh, it's certified,
do.
it's rated at this." Yeah, maybe, but it doesn't necessarily mean it's tolerant to a huge quantity of wideband noise. It should always be avoided. You should try to minimize how much noise your gear has to deal with.
Yeah, particularly like when you're buying capacitors for bypassing noise and stuff like that, or filtering noise, where, and I'm picking on a capacitor because it's probably the most common device you'd use for high frequency to try to absorb high frequency energy. But capacitors come. If you ever looked at a catalog for capacitors, like you just pick on a polypropylene cap, thousands of different variations,
sums.
and they all have different specifications on how they handle certain frequencies. And even then the specs don't tell you that. Really, the cap specs are going to give you, there's simple specifications, the tolerance and the capacitance level and the voltage rating, but beyond that, there's only 3 or 4 specs on a cap. You really don't know until you throw it in situ in the circuit and go, all right, well, what's it doing? And then bombard the circuit with the noise or what you anticipate to be the noise and see what happens. So what we're getting at is once this gear hits the real world, all bets are off if it's going to actually perfectly function the way it was designed to. There's going to be glitches,
Always is.
Yeah, which brings us to audio. And that's the one thing we were talking about where we're getting into, particularly when you're hooking a computer up, which is a noisy device, via an electrical conductive cable, USB, SPDIF, whatever, anything that has copper or conductor in it, right? As soon as you tie that computer with a wire cable to the audio system, you're now transferring a percentage of that noise from the computer into your audio system. Given. No way around it. Going to happen.
Well, theoretically, it's possible not to, but
Yeah.
in practice, that just about never happens.
Yeah, right.
Yeah.
Yeah. To say that noise won't travel down the shield of that cable
Right.
is stupid, would be silly. It
Yeah.
does.
Another common issue is I think people think shields are perfect. They work. And although shields are functional, people need to understand there's big differences in the quality and the benefits of the shield. Shields are typically designed to shield noise that causes an issue in that circuit. But when you're dealing with something like high-end audio, it's much more complicated than that, because as audiophiles, what we're listening to typically is trivial nuances in the audio that maybe the designers didn't really
That's the last
concern themselves
percentage
with.
we're worried about.
Right. And so maybe you can't hear it, but maybe you can. And if you're seeking the best of the best, these things should be there should be some attempt to mitigate these things. Because, of course, we're working well outside of the norm. It's not necessarily that the device won't function if you have noise. It'll function just fine. You could have incredible
plays
noise.
music.
It'll work.
Sure.
The question
For the
is,
most part. It should.
Yeah, right. It would have to be pretty nasty for it to not
Might
work.
skip once in a while on a D-Day or something. If you got a really noisy computer,
Right.
you might miss a beat here and there, but nothing major.
But thinking in absolutes, a feather deflects the strongest bridge ever made.
Sure.
It's just a question of how much. It may be immeasurable, but it's not zero.
Well, it's certainly audible, and because I found it to be, and it's something we addressed in the cable designs years ago. Coming from an RF background, I mean, I've seen it, I've dealt with it. It gets into everything,
Well, I have a real scenario where I ran into this in my computer. I had a USB mic, and my power supply was at its limit. It was a good quality power supply.
The computer power supply?
Yeah. But I got a different graphics card, and I was, at the minimum required,
not good.
power supply.
Yeah.
And I couldn't hear anything, but everybody else that was listening to what I was saying was like, there's just like a constant noise that they could hear from my power supply.
Right.
So
It's
I couldn't
saying-
hear it.
It's saying,
Is it-
help me,
Yeah.
help me.
It varied with the GPU load.
Yeah.
So you could actually hear the frame rate effectively
Right.
in his microphone. It would sound like a motorcycle.
Yeah.
Like a dirt
I couldn't
bike.
hear it though.
Right.
So from my end, it's like everything's fine over here.
Yeah. Yeah, which I mean, that's going to happen. And the same thing happens in audio too when you're dealing with noise, but also just power supplies in general. An amplifier, is typically at peak draw. It's at its limit. You're taxing the power supply and the amp, and it's dealing with it at an audible rate. You got bass notes coming out of this thing. It's driving a 4-ohm speaker or load or whatever. And, so it's the same kind of thing occurs where it's like it's huffing and puffing. And so, in other words, what I'm saying is, people say, well, it's got a power supply, so it's made to filter it out. But
Right. It's made to.
yeah, right.
But it's only so
And a
effective.
steady state, drawing no real power, it sounds like it's doing a great job. But when you start using it, and now you throw noise into the mix at it, now it can't always deal with it well.
That was at probably about 90% of its design capacity.
Yeah.
So it wasn't like beyond the limit or anything,
Right.
but it was right there.
But line level devices are the same problem, and particularly D-Days, like Paul was talking about D-Day converters in particular, because you're hooking, typically the one cable you're hooking into a computer is a USB, and so noise travels down that. So what he was getting at is you can buy filters that go in line with USB, which I know IFI makes some pretty effective ones they're designed to try to absorb some of this noise from getting through the cable into your D-Day converter or whatever you're hooking your
Right.
computer to, and they work. And I mean, they're engineered to get rid of, some of the noise. Not going to get rid of all of it, but that's not the point. You're never going to get rid of all of it. the idea is to drop it down enough where it's fairly insignificant.
Yes. Certainly you could achieve a level where the noise is not noticeable. Doesn't need to be perfect, but it's very difficult to know what that level is because different people have different amounts of noise, different issues, and the different hardware has different tolerance for these things. Some DACs tolerate noise well, others do not.
Right.
Depends on the design. So it really depends on your exact situation, your cabling, how it's arranged, how close it is to other things in your home, whether or not it's parallel to AC power in your wall or something like that, and more of the radiated noise coming off of that AC line is going to get coupled into this USB cable or things like that. There's a huge multitude of situations that could arise that would impact how much noise you get into your system. Simply moving the system could change how much noise you perceive. Or maybe the environment you're in, it doesn't matter at all. You can't hear anything. That's possible as well.
Totally. In that sense, don't worry about it,
Yep.
But, I mean, people that make critical gear too, or outside of audio, you're talking about medical gear and stuff, they have to deal with this. They have to design power supplies and stuff. This stuff's got to be reliable. If it's pumping a microliter of medicine in your body per minute or something like that, that's got to stay pretty rock solid. It can't. You kill people when that thing goes flaky. So,
Well, yeah.
there's that kind of stuff. They pay a lot They pay a lot more attention to noise for sure in their power supplies, their systems,
absolutely.
all that. But in audio, it's an afterthought. It's not really thought of, but it's still a critical system when it comes to listening to music and
If you care enough.
the levels your people are at with resolution. Yeah, it's audible. So I mean, for like another filtration like the example, the digital AC. We have a cord called the digital AC. We've had it for 20 years now, and it's specifically made to drop noise levels, high frequency energy down like up to 40 dB. And we've been dealing with this a long time. We use these on our computers in here and stuff like that. And it's not that you can, like, the computer runs faster or anything, right? We can't do a speed test and go, oh, look at that. It's not about that. It's about keeping the stupidity out of it all. You know, you don't need glitches in your data. You don't need issues. You don't know what this noise causes until it's too late. You know, it's additive, and not only that, it keeps the noise out of our other systems here in the building. You know, we're not allowing the computer to dump noise backwards through its cord into the rest of it. Which here we've got 2 computers, we've got mic preamps, there's a lot of stuff in this room where we're talking, right? And
it's a fair number of things.
Bottom line is a cable like that was designed with filtration. It is designed to isolate the noise leaving the computer as much as coming from the wall, and just keep it away from the rest of the stuff in the room. So it's things like this where noise is additive in an environment. It's additive, and people don't even realize how many things in a home are generating it. Anything that plugs in a wall probably is generating some amount of noise.
Probably.
Pretty much.
Something. Everything.
Yeah. Pretty much.
Yeah. So, and a laptop even running on battery, it's still the processor.
It's radiating a little bit of noise.
Yeah, right. Which isn't an issue because it's not connected to anything, but it can be if you get it close to something.
Yes.
So, yeah. So.
And then we switched from LTE to 5G, and now we got 60 gig millimeter wave that nothing was ever designed to, handle, and all kinds of.
Yeah, that is a big issue, actually.
Yeah.
In the early days of cell phones, you remember it was easy to find devices that you could couple the cell phone, the GSM noise
900 megahertz,
into the device, and you would hear that noise of the cell phone trying to communicate in your device. Now you don't pretty much at all. Even if you put your phone right next to something, you do a speed test or you send some data down it, usually you don't hear it at all. And that's simply because when people are making the devices, when these devices are being designed now, they know that's a reality. People have phones nearby, and so they ensure that the devices could mitigate this
They've
noise.
slowly worked, like car systems were like that too. Remember, you'd always hear the phone in the audio system? Yeah, they've slowly worked to mitigate, filter out, create probably a holistic filter in the car's environment to dump that noise somewhere so that you don't actually hear it.
The trouble isn't that you can't get rid of the noise. It's that usually in the design, they don't know what noise is present, and it just costs money to deal with it. So maybe you don't have this frequency, or you don't have that much energy of this particular frequency radiating down your USB line or passively or something like that from device to device. That doesn't necessarily mean that you wouldn't benefit from having a filter in there, but it costs money.
Right.
So people aren't really going to put the filters in to deal with everything that could exist, because you need typically circuits tailored designed for different frequency bands. And it's just as expensive.
You have to be practical in engineering these things. You can't.
Yeah, you're not throwing $100 of filtration at something that's probably not going to matter for most people.
Yeah. But bottom line is that in the end, I think people just need to realize that the noise sources exist throughout a home environment. It can affect your listening pleasure.
Potentially.
And it's not a hum, it's more like a noise level, it's a hiss, or it manifests itself. Really what it does is it masks the low level detail that could exist. It's a masking effect. You just don't, sometimes you don't even know it's there till it's gone, right?
Usually you don't.
Because all of a sudden you go, oh, how come it's so dark or quieter sounding? Like almost like it's off, right? And it's like, oh, I put this filter in there. It's
a
like,
black background, as it were.
Black background is the technical term that we use in audio, and that's what you get. That's your goal, kind of, is when you get to that last 1%, is you're trying to eliminate these factors, in a playback chain. And so anyway. Hope that helps people to understand, where we're coming from. It's a complicated thing. It's not easy to understand. It's invisible. It's magic, whatever you want to call it.
It's like magnets. How do they work?
Yeah, well, that's true. Yeah, especially the ones that they use in these fancy schmancy motors in the electric cars nowadays. Aren't they making all kinds of like funky shapes for magnets and stuff like that? And
they're getting a little bit more advanced in the simulation and design.
Yeah.
It's not like it was in the 1800s.
Yeah, it's wild, actually, when you look at it. And it's actually, once you see it, that's simple. It's
obvious
simple.
in hindsight.
Right? Yeah, right. It's funny,
of course.
Right? Yeah, to get another 5-10% out of the motor.
That's the thing. If you look at what everybody's doing, they're all trying to do the same thing, but they're all going about it in different ways.
Yeah. Well, patents probably help.
Well, that too. Yeah.
It's like going to pay us to use that idea, but anyway, yeah. That's, I think, enough said on noise for now. But if you run into noise issues, you can always send us an email, and we'll try to help you pin it down. But Usually it's something in the house. Turn everything off.
Yeah, that's a good start. Yeah.
Except your audio. Then start turning things on and see where it goes.
You know?
Sooner or later, something you'll turn on and
It's
go,
like, it's the fridge.
there it is.
Yes.
Yeah, that's one way to go. Kill all the breakers except your audio system.
Yep. That's why it's usually a good start to have a dedicated line if you can.
Yeah, right.
A line separate from all the other things. It doesn't eliminate noise, but it helps reduce it a little bit.
Yeah.
Home run for your audio.
Yeah, you're kind of ensuring that the, the computer in the kids' room next door isn't on the same line.
That's a good start. Yeah.
Right.
So, yeah, on that note, thank you everybody for watching. Take care of yourselves. Thumbs us up if you like this video. And don't forget that we have pillows at abyssstore.com. And
Abyssstore.com.
mugs and other things and stuff like that.
Oh, and we also have this show and every other one available now on our podcast. As a podcast, that is. Available at all your favorite podcast places.
Yeah. Hey, Siri, play Top of the Line Show podcast. I bet you're going to hear us right now.
So exciting.
Yeah, that's enough of that. Thanks, guys. Take care.